Hello, students. We're about to start section 2.2 on page 139 in your course pack. It says lesson 2.2, a coordinated effort. The learning objectives is to use a rectangular coordinate system to connect data to graphs and interpret graphs. It says believe you can and you're halfway there. Theodore Roosevelt. Okay, now let's look here at the bottom. It says one of the most common ways to measure the strength of the United States economy at any given time is the percentage of adults who are willing and able to work who don't have jobs. This is commonly known as the unemployment rate. These tables display the average annual unemployment rate for the years 1993 to 2018. This is an example of time series data, which are quantitative data that have been collected at different points in time. A time series graph displays values on the y-axis compared to equally spaced time intervals on the x-axis. Now we see all of these values here. Now we're going to have to possibly flip back from page to page, but what you could do as I write down the answers on the other page, you all can look at page 139 to go along with the answers that I will provide you. Okay, number one, it says use the table to write a verbal description of trends in the unemployment rate over the 26-year period. Okay, now from 1993 to 2000, the unemployment rate went down. Now, I'm not going to keep writing out unemployment rate, but as you all would see here, from 2000 to 2003, the unemployment rate went up. From 2003 to 2006, the unemployment rate went down. From 2006 through 2000, from 2006 to 2007, it stayed the same. It stayed the same value. Okay, now from 2007 to 2010, yes, from 2007 to 2010, it went up. And then from 2010 to 2018, it went down. So 2010 to 2018, it went down. And we know that's the unemployment rate. So it says with enough effort, you were probably able to write a reasonable description. But because there's so much data in the table, spotting the trend isn't exactly a simple thing to do. Next, let's look at the same data displayed in graphical form. So we have this data in graphical form. When I look at this graph, two things occur to me. It's a lot easier to see the trends that it was from looking at the table, and the graph looks kind of like a sea monster with an elephant trunk, which is totally irrelevant but still pretty cool. Use the graph to write a verbal description of trends in the unemployment rate, then explain why the graph makes it easier than the table did. Okay, basically, the graph makes it easier because we have a visual representation instead of numbers in the table. And then explain, it says use the graph to write a verbal description. Okay, so this is why the graph is easier. But the verbal description is the graph's trend is the same as it was in problem 1. So we don't need to rewrite all of that again. It's the same thing as it was in problem 1. Okay, now it says without the numbers running along the bottom side of the graph and down the left side, we wouldn't be able to understand any of the information the graph provides. Those numbers provide the scale for the graph, and they're always crucial in drawing a graph. Each of the number lines that we write the scale on is called an axis. The plural of the word is axes. Let's take a look at how we might add some new information to the graph. Okay, now it says here we can actually skip over that part and we can get on to page 142. It says, since we didn't need to worry about negative years or negative unemployment rates, the graph we drew earlier only showed positive values along each axis. But there are plenty of examples of data where negative values make perfect sense. So a rectangular coordinate system is often set up like this. It says here, the process of locating information on a rectangular coordinate system like the 3.7% unemployment rate in 2019 is called plotting points. We identify locations by writing the two coordinates together inside parentheses, like this, 2019 and 3.7. What are the coordinates of the origin of in the rectangular coordinate system above? The origin is always where the x and y axis meets, and that ordered pair is 0, 0, or the coordinate is 0, 0. Now, number 4, it says, look carefully at the numbers on each axis. What distance does each box on the grid represent along the x-axis? What about the y-axis? Okay, now if we look at the x-axis, starting at the origin, we always start at the origin. We have 5 tick marks here. So each one of these are going up by 1. So the x-axis goes by 1 unit. The y-axis, we start at the origin. We have 5 tick marks. We go to 10. So that means that they were 2 each. So the y-axis goes by 2 units. So that lets you know what each of these tick mark value is. Now it says here, apply each of the following points on the rectangular coordinate system above. Label the coordinates of each point. Now, this is what happens here. We need to graph x and y. Now, there's a couple things that you need to know. Number 1, we always start at the origin. Whenever we start to plot a new coordinate, we always start at the origin. Now, x always goes first. X has 3 characteristics. It could either go to the left, the right, or stay. Again, left, right, or stay for the X value. Now the Y value is the second value we look at in the coordinate and is also the value we stop on. So the Y value has 3 characteristics as well. It either goes up, down, or stay. So let's go through and plot these points. So we have 4, 0. We start at the origin. We have positive 4. So we go to the right 4. Because remember, these are 1 unit. And then y is 0. So that means we stay here. Because y ended here. So it'd be 4, 0. Now we have 0, negative 8. We go back to the origin. X is 0. So that means x doesn't move left or right. It stays here at the origin. but y is -8. And since y goes by twos, we'll go down 4. So this will be 0, -8. Now we go to C. We start at the origin. We will have to go to the left 3 and then down 2. And we plot that point. So we add -3, -4. And then last but not least, we have D, which is 2, 7. We go back to the origin. We'll go to the right 2. And then 7, that's in between 6 and 8. So we add 2, 4, 6. And it'll be right in the center between 6 and 8. So we add 2 and 7. And so we plotted all of those points. Now we move on to page 143. It says, what temperature is this thermometer displaying? We could say we do not know. Explain why the thermometer is pretty much useless. There are no numbers to indicate the temperature. Now it says, what are the coordinates of the point drawn on the graph here? We could say we do not know. Explain why the graph is pretty much useless. It's basically the same as number 2. There are no numbers on the x or y axis to indicate the value of the coordinates. And that's why they are useless. It says every graph has to have a clearly labeled scale on each axis. A graph with no scale labeled is every bit as useless as the thermometer with no numbers on it. There's no reason the scale has to be the same on both axes. If a graph contains points like 10, 4,000, and 23,000, using the same scale on the x and y axis would lead to a graph that's very difficult to read. And it says try it. I'm not trying that. That's going to be too large of a graph. If there are certain points on a graph that are important for some reason, you should label the coordinates of those points directly on the graph. Being able to understand the connection between a graph and the information that it illustrates is by far the most important skill in graphing. If you can't interpret the meaning of a graph, it's just really bad art, which is a very true statement. All right, now we go here to the back. It says almost everyone is interested in gas prices. They can have a very real effect on a household budget. The data in the following table show the average price of a gallon of regular unleaded gas in the United States in January of each year from 2006 to 2016. Write order pairs of the form years after 2006 and then price per gallon for each pair of values. Then plot the points on the graph. Now, if you look here, years after 2006 have been done for us because in 2006, that's not a year after 2006, so that would be year 0. It's the exact same year, and then we have the following years. Now, they want us to write this as an ordered pair. So 0 would be the years after 2006, and the price of gasoline would be this value here. So now we would do this for all of these. So these are your X and Y values. And the reason why I'm not writing the $ with the cost of the gasoline is because it's already assumed to be in dollars. So we don't have to write the $. So we're almost done writing in these values. Now, for number 6, it says connect the points you plotted to draw a graph and describe what the graph illustrates. Then add a verbal label to each axis that describes the information it represents. Okay, listen. Instead of me graphing first, we know that this is the X value here, and this is the years after 2006. And then down the side here, we know this is the price per gallon. And then we know we will have a dollar sign here because the price per gallon will be in dollars. Now, we go through and graph this. We have 0, $2.32. We know it'll be close to the 250. Then we have 1, $2.27, which would be more like close to the middle here. Then we have 2, $3.05, which would be slightly over the $3 mark. We have 3, $1.79, which would be about the midpoint of 2 and $1.50. We have 4, $2.73, which would be almost the midpoint of $2.50 and $3. We have 5, which is 309, which still should be a little slightly higher here than the 305. We have 6, $3.40, should be close to the 350. We have 7, which is 335, which should be slightly lower. Then we have, oh, I need to erase that. I need to bring that over here. Okay, number 8, we have $3.32, which should be close to the middle here. And it's still slightly lower than $3.35. And then we have 9 and $2.11. And then 10, we should have $1.97, which is close to $2. Now they tell us to draw this and connect the points. Okay, so that is our graph. Now it says, what was the highest price of January gas between 2006 and 2016? Is the answer based on the graph different and why? The highest price was what, 2012? So it'd be $3.40. Okay, it says it's the answer based on the graph different. No, it is not, but can be hard to tell because it is a little less than $3.50. All right. Oh, and just a further explanation. You can't really tell if we didn't have the numbers up here and we were looking at this graph, we couldn't tell that this was $3.40. We would know that it's less than $3.50, but that's why I said it's hard to tell. Okay, now we come here to page 145. It says number 8, when was gas most expensive? Okay, so basically they're asking us when was it most expensive? It would be 2012 because that's when the $3.40. Okay, number 9, when did gas prices stay relatively level from one year to the next? Okay, so basically relatively level It would be like 2006 to 2007. There's only a 5 cents difference there. And then we have from 2012 to 2014. Between those 3 years is only what, about 8 cents difference. So 2012 to 2000, let's say 2014. Okay, it says over what time spans were gas prices rising? Okay, so the time span that gas prices were rising were from 2007 to 2008, and then we had 2009 through 2012, and that's it. 2007 to 2008, and then 2009 to 2012. All right, now it says over what time spans was gas getting cheaper? Gas was getting cheaper from 2006 to 2007, and then 2008 to 2009, and then 2012 to 2016. Those were the spans when gas was getting cheaper. What was the largest single price change in 1 year? The largest single price change in 1 year was from 2008 to 2009, and it was a difference of $1.26 from 2008 to 2009. All right. Explain why we didn't bother to include negative values along either axis when drawing a rectangular coordinate system for the gas price. Time and cost of gas has no negative value, as you cannot have negative time or negative money when it comes to the gas prices. Because that would mean if they had a negative value for the gas prices, that would mean that they owed you money for pumping their gas, and we know that's not going to happen. Okay, now page 146. It says, if I offered you one of two accounts detailed below, which would you choose and why? Okay, now for me, it would just depend. If it was just 4 years, I would choose account one. So I would say if only 4 years time, then I would choose account one. If it were a lot more years counted, I would choose account two because every year interest increases. Yep, every year interest increases, which means over time it will overtake account one. So that would be my choices. Now for 15, it says when we plot points on a coordinate system that correspond to pairs of data, we call the results a scatter diagram or scatter plot. For the bank accounts in the two tables below, create a scatter diagram for each. First, you will need to complete the table using skills we practiced earlier in the course. After writing ordered pairs, decide on an appropriate scale for each axis. Then plot each point. It will probably be a good idea to use different colors or different markers for each account. Okay, listen. Now, based upon what we did earlier, as far as the accounts and interest and everything like that, we could figure this out here. So we went 1,060, and so on. So now our next value here, if you notice, this is going up by $60. So this would be $1,300. And then we have to do 10 years. So 10 times 60 would be 600 more. So that would be $1,600. And then 15 times 60 would be $900, which would take it to $1,900. In 20 years, that'll be 1,200, so that'll be $2,200. And then 25 years times 60 will give you $1,500 plus the 1,000 will be $2,500. Now they want us to write the ordered pairs. It'll be 0 and 1,000, 1 and 1,060, 2 and 1,120, 3, 1,180, 4 and 1,240, 5 and 1,300, 6 and 1,600, 7 and 1,900, 8 and 2,200, 9 and 2,500. Now we go over here to this other chart here, which we notice is basically compound interest. Now, what I'm going to do, I'm going to write out the value. If you notice here, this went up $50. So from our previous lesson, going here over to Desmos, to get us to $50, that was 5% interest we were multiplying by, and I just want to show it to you. And that would give us the $50. So each year this is going up by 5%. So what we could do, what we did in the previous lesson, remember, we have 1,000 times the parenthesis 1.05. And then we would take it to the exponent of these years. So now, we will go, first of all, the 5-year mark, we'll take it to the 5th power. So that'll give us 1276.28. Then we could change that 5 to a 10. Then that'll be 1628.89. And change that 10 to a 15. It'll be 2078.93. Then change that 15 to a 20. It'll be $2,653.30. And then finally, we'll change that 20 to a 25. And it'll be $3,386.35. Okay, and as you see here, we start seeing the overtaking when we get here to about the 10-year mark. It could have happened maybe at the 9th year, but we know definitely at the 10th year, that's when this account 2, started being more lucrative. Now, one thing I want to talk to you about here is this growth factor here. The reason why we have 1 instead of just the 5% is because this 1 adds back in the $1,000 that we originally had. Like I would say this here, if you put $1,000 in the bank, and then after a year you came to the bank and you only had $50 in the account, you would talk to a manager because you know you're supposed to have that $1,000 in it with it also. So that is what the 1 does here. So if it would have been at 7%, it'd be 1.07, and then it will give you exactly what's in the account. So now let's do the ordered pairs. It'll be 0, 1,000. This will be 1, 1,050. 2, 1102.50. Then 3, 1157.63. 4, 1215.51. 5, 1276.28. 6, 1628.89. 7, 2, oh, you know what? No, I made a mistake here. This is supposed to be 10, and this here is supposed to be 15. So it'd be 15, 2078.93. Then this will be 20, 2653.30. Then this will be 25, 3,386.35. And those will be all of the ordered pairs. Now, on the next page, it asks us to do the graph here and plot these points. Okay, so first of all, we look here. We want to do the axis and the point values. If you notice for the x value, the years, we go basically from 0 to 25. So if you look here, we can go basically by ones here, but on the thicker lines here, we'll go by twos, but we're still going by ones because of the middle line here. So we covered all of the years here. We got to 26. Now on the y-axis here, we want to talk about what's in the account. Now, if you look here, our account starts off at $1,000 and it grows all the way up to, at most, it'll be $3,000, almost $3,400. So here we can go by 400s. Well, really 200s. This would be 2, 4, 6, and then this would be 8, then 1,200, 1,600, 2,000, 2,400, 2,800, 3,200, 34, no, 3,600, not 3,400, 3,600, and then finally 4,000. Okay, so now these are all of our points on the axis. Now, the thing about this is we didn't tell what the x-axis and what the y-axis is. So basically, the x-axis is basically our years, and then the y-axis is the account value, which would be in money. It's the account value. So now we need to plot these points. We had 0, 1,000, which would be here. We had 1, 1,060. So this is 1,000, 1,060 would be somewhat here. Then we have 2, 1,120 to be a little higher. Then we would have 3, 1,180 to be close to 1,200. Then we would have 4, 1,240. Then we would have 5, 1,300. And then we would have 6. We don't have 6. We jumped to 10. So I did make an error. I didn't catch that at first, but let me come back here. This is supposed to be 10, not 6. And then 15, 20, and 25. 15, 20, 25. Okay. So now we will go here to 10. And 10 is what's that, 1600. And then we will go to 15, which is 1900. So 1900 will be about here. Then we have 20 for 2200, which is about here. 25, and then we had 2500 to be about here. Now we could connect these points. Okay, so that is the first. That is account 1. Okay, now account 2, we got 0, 1000. We still will have the same place. And then we will have 1, 1050, which would be a little bit below here. And then we will have 2, 1102. 2 would be a little bit below here. And then we would have 3, 1157. Should be a little bit below here. And then we would have 4, 1215. Should be a little bit below here. Well, actually, it should be above the 1200, but a little bit below. Okay, and then we have 5, 1276, which would be a little bit below. I mean, it'll be, yeah, 5, 1276, be a little bit below the 1300. Now, what I'm going to do here, I want to connect these points here. I want to connect these points just a little bit here. So then now we jump to 10, which is 1628. So that'll be a little bit above here. And then we will have 15, which would be 2078, to be a little bit above 2000. And then we have 20, which is a little bit, 20 is 2653. So it's a little bit above the middle here. And then we have 25, which would be a little bit above half here, about, well, right about here. Okay. All right. So that is the graph, and that's freehand. Of course, you all could use a straight edge to help you all out here. Okay, 16. Explain why you chose the scale that you did for each axis. To make sure that each point was represented. And did not have to go beyond the graph. Because if I would have used, say I would have used half, we'd have to go beyond the graph to get to 25. So that's what I mean by not going beyond the graph. Okay, now 17. It says use the two scatter plots to write a verbal description of the differences between the growth of the two accounts. More detail is better. So just to say this, account 1 starts out higher than account 2, it looks like a line for account 1. Account 2 starts off slow, but eventually outperforms account 1. And is more of a curve. Number 18. In some cases, if the pattern of points in a scatter plot is relatively clear, we can connect the points to complete a graph. Do that now, drawing two graphs that represent the growth of two accounts in question 15. How would you describe the two graphs verbally? Okay, well, account 1 is a line. Account 2 is curved upward. So that's basically it. All right, so we are done with section 2.2. And if you have any questions, feel free to email me. Have a wonderful day.